Putain, c'est 02 là.
Je ne sais plus le numéro, donc il faut vérifier. Fichier page peut-être. Sinon tu vas sur agenda. Sinon pour les tickets, je t'avais envoyé un lien. Mais tu les as aussi dans le docket, hein, parce que si il y a pas de docket, tu peux les donner. Je vais être sûr si. De toute façon, je me demande avec de vérifier.
Yeah.
Yes, good.
Okay, I propose that we get started. This is the 6TISCH work group meeting. We have an hour and a half. We have a lot to discuss. Before we start, however, I need to remind everybody of the note well. If you know of any IPR that we're discussing, whether it's yours or not, you need to disclose it. If you have any questions, go to these references or ask your favorite workgroup chair or AD. As a reminder, we are taking minutes. We are recording the meeting and the presence is logged, and all of this will be published to the mailing list at the end of the meeting. Administrative blue sheets will be circulated real quick. We have, I believe, scribes, the Etherpad scribes, so Dominique is helping. Oh, thank you very much. And then Jabber, thank you, so everything is covered. If you want to follow, we're doing it on the official Etherpad, so you can follow the minutes and complete whatever is not complete. This is the agenda. Let me move a little bit over. As I told you, we have an hour and a half. We'll start by a little intro. Pascal will do this. Then we'll go, I'm sorry, new chart and status. Pascal will do this. Then we'll have a first half on dynamic scheduling, second half on security. And then we have a couple of minutes for any other business. Is there any comment about this agenda? Anything you want to add? Anything we have forgotten? Please raise this now. Okay, here nothing, so let's write down in the minutes that the agenda is approved. So let's get started by the first item, intro and status. Pascal, you want to do this?
Thank you, Thomas. So for those who are new to the IETF, a gentle reminder that if you go to the agenda page of the IETF 97, you will find a line with 6TISCH. In this line, there are a number of those little buttons on the right. One of those buttons gives you a link to the Etherpad that Thomas just indicated. On this Etherpad, we are taking minutes live. So you can read what was just said if you did not understand. So maybe there is somebody writing about it. Yes, assuming that somebody who's a scribe understood, but we have very, very good scribes in this room. And you may also write your own words of what you understood if you think that the scribe did not capture it correctly, which is impossible, but who knows. So this is all available from the agenda page of the IETF. And with this, let's look at where we are with this working group. So I see that Suresh has come in the room, and that's a perfect time, because the first item in this list is the status of the minimal draft.
Yeah. Hey, Suresh Krishnan, AD. I just did my AD eval and I sent out this thing like 3 minutes ago. So there's some minor stuff, but it's mostly good to go. But there's some stuff I want to see fixed, like especially some of the shoulds. It's not clear like why they are shoulds. So that's one thing. And some stuff that's like redundant from the terminology document. So it's like redefinitions, but they are slightly different. Okay, so for example, the slot frame is defined again in this document, and it's different from what's in the terminology. So inconsistency gone. So try to minimize the duplication of text. So it's inconsistent, but minor stuff, like they can all be fixed pretty quickly.
On this particular one, the terminology is not shipping yet.
Right, but like the right terminology needs to be somewhere, and everything else needs to refer to it. Because like if slot frame is defined one way, right?
My question is really, is it a normative reference that will hold this draft because we don't have the terminology shipping? Should we ship the terminology right now so we can ship this one?
No, like you can ship it whenever, right? The document gets held as the RFC editor.
Well, so it will be held as long as the terminology doesn't ship.
But it can go through all the IETF process and be done with it, right? Like, so we don't hold it in the IETF, right? Like, so it goes like, and goes into like there's an RFC editor state called misref. So it goes into misref until the other document comes in, okay?
So that really means that we need to ship terminology if we want to ship this one.
Right.
Number.
Or like the other option is like, just define it here. Don't do it in terminology if no other document needs it, right? But I don't want two places defining things differently. Okay.
Gotcha.
And another thing is like, again, minor thing is that it's redefining a lot of RIPL stuff in this document, right? Like the ranking algorithm is getting like, there's like a huge section defining the ranking in this, which I don't think is needed because the RIPL document defines it pretty well already, right? So like, just like minimize it to show like what's different from there or what additional here instead of like putting the whole thing. So if it's like minor things, but get rid of them, and then because it's going to come up again somewhere else. And I looked at the IEEE stuff, and like most of the redundancy is gone, and I'm facing like a huge issue in PTP MIB, right? Because one of the ADs here is holding a discuss, like because of the lot of copying of text, so I just don't want that to be there. So it's like mostly gone, and like there's some minor stuff, but that's all fine. I don't want that fixed right now. Okay.
Thank you.
Thanks.
Thanks so much.
Tero Kivinen. I have one comment about the minimal, because yesterday we have this plenary where people were saying, oh, we don't need a PCP saying don't use default passwords. And then we have a document which is saying, oh, we use well-known keys, and here's a default password or default key. So in the security section, it says still that, okay, we use this key when we are using for K1, and there is a possibility using K1 is equal to K2, and in case we are not using that, we are using well-known keys. Or somehow configured keys, but it's, the well-known keys is one option there. And I think we should actually remove all of that. First of all, okay, the minimal testing is now done, I hope. So we don't need that to have this interop key there anymore, because it's not for the shipping products, it's for the minimal testing. So now we don't need that anymore. So that sentence should be going on. And I would actually want to remove also that stuff about well-known keys, because I think it's actually a bad idea to say that, yes, use a well-known key, and that is, everybody knows it. There is no attacks, admin as a password. Who cares?
And K1 is limited use, right?
Yeah, but you can still do quite a lot of it.
Okay, Suresh Krishnan. So, Tero, I read that too, but like I thought it was like endemic to this thing being minimal, right? Like, so there is better things. One thing I can do, like maybe that'll help, is like send this document for an early sector review. So like I can recommend you be the reviewer because you already read it, right? So when I'm doing the last call, I can send it off to the sector as well. I'll ask the security ADs to take a look at it, and then we can fix them all as like last call comments. Okay?
Because this has been an infinite discussion already, right? So if we reopen that wound, I don't know when. Okay. Yeah. Okay.
So
let's do it early.
Just to clarify that, Pascal, if that's an infinite discussion, it will be, because like there's like 2 SecADs, this document needs to get passed, right? So like we'd rather have the bad news early and try to do something about it than like wait for the IESG telechat. Okay, thanks.
Xavi Vila Jordana. So I think in the text says it's just for interop testing, this key one, but you already said that. So.
Okay, so about 6TISCH protocol, I'll give you the milestones, but we are getting close. There is a lot of work happening, closing all the discussions, so we'll have a status in this meeting. The first generation of it has been tested. We got feedback from the test and from the test, yes, from bug test, and the code that we have now is fixing those the issues that were found there. SF0 will have a status today as well. It's probably a little bit less advanced than 6TISCH protocol. The architecture has been very, very stable. There's maybe some missing text about tracks. We need to rediscuss a little bit the concept of tracks. I don't think it's completely closed. And we have SF1, which won't be discussed this time because we are not ready, but the authors promised that they would be coming to the next IETF in Chicago, and they will be coming to us with new work on there. Run 6 law, you know, there was this the compression of the REPL artifacts in the IP packets has been split in 2 documents, so the paging dispatch and the routing dispatch. Paging dispatch is very small. It's how you extend the 6LoWPAN addressing space. And then the real work about compressing the REPL artifacts is done at roll, and it's the routing dispatch. Both of them passed the ISG review. The paging dispatch is actually in OAuth 48. For those who have not been through this process, that means it was in the RFC editor queue. RFC editor has been doing his edit to make the text clean. But since he changed the text, the last thing that happens is the editor comes back to the author and says, please check my changes. Are you okay with them? You've got 48 hours. Okay, and so the paging dispatch is in the OAuth 48 state. Backbone routers being split. We had an interesting 6LoW session for those who were there about the RFC 6775 update, which is mostly extracted from the backbone router for the piece that updates 6LoWPAN so that the backbone router now will only have what is new to this functionality, and what is an update of 6LoWPAN will be a 6LoWPAN update. So there was this discussion about adoption. I hope that we'll call adoption and get there. And last but not least, the piece of the 6LoWPAN that solves the security issues in the update requirement draft is called 6LoW8 address protection for neighbor discovery. It was adopted at 6LoW as well. Milestones. Okay, so we have shifted the dates a little bit from the original milestones. So now we hope to be delivering the 6-stop protocol and the SF0 at the end of this year. I think we can make it for 6-stop. I'm not 100% sure we can make it for SF0. We'll probably slip a few months for SF0, but let's keep the hard work and let's try to make December. So action plan, we are still working with this agile, let's do the specs, the code, the test, and do that in a loop. We have a complex action item about security. We are chartered to work on the joint process. There are really 2 angles to the joint process. There is the rich and the poor, I would say. And so now we're working on how we can actually make the 2 look like a staging process. And that will be the second half of this meeting. We'll be discussing about this. And Michael actually on the mic is responsible for overhauling this work.
Michael Richardson. Actually, I was curious to know if there are plans for a plug fest or plug test prior to Prague, if anyone has thought that through again.
Thomas, we have announced a Plugfest in Prague. I don't believe there will be one before that.
Okay. And do you think that the online thing that you talked about last time is there's some stuff we could do with that? Is that worth maybe?
So this is under development, and the idea is to use it in Prague. So
okay.
It will be very strange. It will be a physical meeting to test an online.
Yeah, but we can talk to each other and look at each other's screens,
exactly.
So that will be good. Okay.
Exactly. So
right.
It would be the first time we will use it, but it will be in Prague.
Okay. Thank you.
Thank you.
Okay, so we'll discuss more. Like we have more than half an hour on this security side. So we'll have the presentation by Michael and the presentation by Malisha about those 2 stages. And with this, Xavi, I will leave you the floor. Please stay on. Yes, I was not.
The camera turns, doesn't matter.
Okay, so I'm going to present the 6-stop protocol draft. We did several updates. Qingwan is the editor, and she cannot attend today, so I will present on her behalf. So the status is we published version 3 a couple of weeks ago, the 31st of October. And in this version, we did several changes. There's been quite a lot of activity in the mailing list regarding this draft. So we kind of tried to address all the comments. So the first thing we did is we add a type field in the 6-stop information element header in order to differentiate the different messages we have. Then we add a cell options field in a request for these messages: add, delete, status, and list. And this what it enables is us to allocate cells of different types, like transmit or reception cells or share. Then we add another function to suggest cells once the node proposes a set of cells to allocate, and then it gets back the response. In this response, if none of these cells can be allocated, then it gets a suggestion of the cells that can be allocated from the other side. And then we had this best effort number of cells in the list response. This means that when I issue a list command, I get a response with as much cells as they fit in the packet as Tero proposed in the mailing list. So the next steps for this draft, we can discuss. I think it's pretty stable now. Maybe one thing is to call for implementers, but out of that, I will be open to other questions or things you think might be add. So I just go through these little changes with it. One, we add in the header, we add this type field here. And with this type, we can differentiate whether the packet is a request, response, or a confirmation. And this is useful to understand where in the state machine we are once we get a packet. So the cell options bitmap is a bitmap that goes in the information element of the transaction. And here we can specify, this is pretty similar to what we have in 1540 with the link options field, but we just have the bits that we need, which are transmit, receive, or share. In this way, when we do a 6-stop add, we can specify the cell we are adding instead of assuming that they are all TX cells. This field also applies to add, delete, status, and list commands, and it has, let's say, kind of filtering functionalities. For example, if I issue a list with this cell options field marking the transmit, I will list only the transmit cells to filter the cells that I want to get on the list. You will see this now. So the request, this is the header we have, and we add this field here. So when we issue an add, we say what type of cells we want, the number of cells, and then a proposal of cells. And these cells will be allocated, all of them using these options. So we cannot have different types of cells in a single request. For the delete, the cell options only applies when the cell list is empty. So delete deletes the cells that we specify here, unless we do not specify any cell, and then it will delete all the cells that are of this type. So for the suggestion, we have this 3-step transaction, and then imagine that we have an add request from a node, and the node is proposing these cells to be allocated. Then the counterpart sees that none of these cells can be allocated in its schedule, so it responds with a suggestion. It says, okay, why don't you try if these ones fit to you? And then the confirmation just confirms the cells that can be allocated from the origin. In this way, we try to avoid the fact that if a node requests cells and the other side doesn't have them, it has to retry a lot, or it has to kind of figure out what are the cells I can use. So in this way, we try to minimize this. And this is when we issue a list command, we want to we want to get as most number of cells in the response, but it's kind of best effort. So we want to fill the packet. And as we do not know if in the packet there are other information elements, and then the payload size we have is not fixed, it's variable. So what we did is we say, okay, you issue the list and you request from that offset that many cells, but if they do not fit, it will send best effort all that fit in the packet. And these are the major changes we have done during this period. So I ask if you think there's something that's missing.
So Thomas Otena, I got some offline feedback from implementers. Little changes that are suggested, and I just received them, and I know we discussed it yesterday, but I just want to say it on the mic, and then we'll do it on the mailing list. But one of the things, it's tiny changes, but one of the things is, if I understand correctly, when you do a list, you ask, right? You ask the neighbor, please give me the 10 first ones, the 10 second ones, the 10 third one, and you wait for, because you ask for 10, and then the neighbor answers with however many fit in the packet. So maybe if the neighbor answers with 6, it might mean two things. It might mean that's it, these are the last 6, or it might mean there's actually more, but not more than 6 fit in the packet. With this in mind, and Tero, I think this was your suggestion. The problem with this is that, well, the inefficiency is that you need to request until you get an empty response to know that this is the end of the list, right? You request, you get 6, and then you request once more, and then you get 0, and you say, okay, that's the end. The suggestion is to add a return code, which means end of list, so that when you get back the last 6, it returns the 6, but the error code, I'm sorry, the return code is, okay, success, but this is the end. So you don't have to request one more. The idea is that for every list command, for every time you list, you receive, there's one less back and forth. Does that seems reasonable?
Yes. So instead of success, we return this code. That means success plus end of list.
Yeah. So what this means is that in some table, we'll just add one more thing called end of list. And then one more. So, sorry, yeah. Let me just get my. Yeah. So one more thing is the generator. So this we have to. This is a little bit more complicated, but the generation numbers GAB, GBA. I think we started with the idea that a mode would only request transmit cells to its neighbor, and so there, if I request to you, then I know I'm requesting transmit cells, and so that's why we have two generation numbers, GAB, GBA, because from me to you, from you to me. But now that we can request cells which are not per se transmit cells, I think the distinction between GAB and GBA doesn't hold anymore, because I can request cells from you to me. So in this case, the question is, could we not just have one generation rather than two? Might simplify things.
Yeah, we discussed this, and I think that because when we did this change, adding the cell options, we didn't want to change everything at the time, but I think that with only a single counter, it's enough.
Great.
And we can decide if this counter applies to any transaction or just to the transactions that modify the state, let's say delete and write.
Yeah, so those are the two comments I got. I'll
Okay.
continue on the mailing list, of course.
One thing I did not report is the status of Tero's draft about the IE that the IETF is requesting for the IEEE. Actually, this draft uses this IE. So obviously, we can't really implement this until we get the IE assigned.
Yeah. So Krishnan, I was planning to start the last call this week, and so I was told by some ADs to start it just after the IETF ends. So Saturday, it'll go into last call, and the idea is to put it on a telechat for the 15th of December. I already told Tero about that's the next telechat that's possible to get it on. There's a
Actually, can you please let us know before that?
Yeah, 3 weeks. Yeah, it's my choice. Two. Yeah, thanks.
So do you know, Suresh, and I see that Bob is in the room as well. Once we can we have an idea of how long it's going to take to actually
Bob is busy with this email.
Bob. We were wondering what kind of time frame we can expect for the allocation of the IETF IE by the IEEE.
Sorry, can I please come to the mic?
Yes,
Can you come to
please.
the mic? Thank you.
Please state your name.
Bob Hiley, IEEE 80515. I should know better. Come to the mic. That's my line. That's the rack. But what I've heard is that it has been approved, and that so now I would expect it's in the next 1 to 3 months.
Okay, because no, it was actually I made one mistake yesterday or the day before because I was confused with the Ethernet. There was this new RFC 7973, which asks an ether type for a 6 low, and I was confused between this and the IE. So if you heard it from me, it was me being confused. So did you hear it from a better source?
Yeah, I mean, the best I could do is follow up with the rack for you if that would be helpful, but
There's no rack yet.
not rack?
This is ANA, 15 ANA.
Oh, 15 ANA. Oh.
So this is the allocation for the 15 information element.
Okay.
So it's an ANA, 15 ANA, and I think their turnaround time is just.
Oh, is the request has been set in, right?
Now we are going to set the request in 50. Actually,
Around.
And we could turn that around in 24 to 48 hours.
Okay.
Oh, awesome.
Okay,
Thank you.
that's really what the question was.
Yeah.
So we could get it before this year, right? This calendar year.
So if the document gets approved on the 15th, I can make the request like on the 16th.
Yeah, and then just make sure, send it to Pat Kinney, but CC me, and then we'll expedite it.
Okay, thank you.
Yeah, I think that's it. Thank you. Okay. Next up is, so I don't exactly know how to do this. Diego, there you are.
Yes, can you hear me?
Red button. Should I press the red button?
If you hear him, don't press the button.
Okay, I hear
It's
him.
got the
Okay.
Diego, go ahead. I
Yes.
see. Oh yeah, we all see you. That's good.
Okay.
Good morning, good evening.
Okay, this is good evening for me. Okay, thank you.
Oh, sorry.
Yes.
So,
Can you,
Diego, your
Yes.
name is written on your mouth. Somehow that's the way it's inserted. So if you could move your camera a little bit so your head goes up.
There we go.
Yes, much better. Thank you. Now you're perfect.
okay. Well, I am the editor of this draft. Okay, this is the SF0 draft, and we have been working for the version 02, and which was published on the October 31st. So I would thank also to the co-authors, Luigi, Maria, and Nicola, okay, who have collaborated with this draft for quite a long time. Thank you. Can you come for the next one, please? So just to recall a little bit what was the evolution and why we have this cell estimation algorithm today. Well, on this draft, in the beginning, okay, we had a specific assumption that they had the application on each node. We have to request the bandwidth. At that time, that was the original idea, and because of that, we used this value from all this request to calculate or to estimate how much bandwidth we will need again to a specific neighbor. Where meaning this was measured on bandwidth units, okay, whichever they were at that time. Then we also consider the incoming traffic and the local application traffic for the estimation, as I said. So for the inception of 6P and SF0, okay, the original assumption is not local valid, so we don't know how many cells or how much bandwidth is required by the application or from any application which is running on the node, and this is why we must do some kind of estimation on the outgoing side. Please, next, please. Okay, so in 0.2 version, okay, we still include the incoming traffic, and we have replace the application traffic, which we don't know how much is it directly, with the outgoing traffic to estimate a new traffic requirement. So we add both of them, the incoming traffic and the outgoing one. However, okay, this is overestimation because the outgoing traffic still includes the incoming one. So after some recent discussion we have on the mailing list, the proposal is to use only the outgoing traffic growth to estimate the new traffic requirement. So this means that we are going to measure this in cells now, from now on, first, and second, that we are not taking into account the incoming traffic from any other neighbors because we don't know which is the destination from each of the traffic coming from each of the neighbors. Since this traffic would end on this node, the traffic can go to any other neighbor, and we are not assuming that you are having RPL on top of it. Since although we have it now, any other routing algorithm can go on top of this. So because of this, we are only assuming that we are going to measure whatever is going out, and then we are going to estimate the next step. Please, next, please. So just to make it, to illustrate what you have thought about this, so we have the alternative one. Okay, it is what we do now. Okay, there's a number of other the requests from outside. Okay, the incoming requests and the number of effectively used cells. I can specify a little bit on this. This is the cells which are used, which are less than the number of allocated cells. So there are some of the allocated cells which are used, and some of them are empty, and we are giving a little bit of over provisioning just to identify if there's a growth in the request or not without losing any packets. So this is the required cells parameter which are sending afterwards. We are sending afterwards to the allocation policy. The alternative 2 means that we add some over provisioning, a fixed number for over provisioning here, and this means that we are just guaranteeing that we are not going to lose any packets because we have always some empty buffer just to detect that we are growing, and because we are growing, we are triggering this algorithm to add more cells. Next, please. But now we have the last one which is still not included on 0.2, but I think this is the most accurate one, that to use only the number of effectively used cells, okay, plus a fixed over provision. So, and this will be the required cells, and that's it. So the thing is, we wouldn't like to imagine which will be the destination. We don't know which is the forwarding arrangement around the different neighbors, and because of that, we don't know which is where to put the incoming traffic, and because of this, we are only taking into account the outgoing traffic to ask for new cells. Then next, please. So the question now is if you agree in using alternative 3. I wouldn't ask it to the public now. Okay, we can go on to the mailing list, but the thing is just to think about if this alternative will be the best one, or if you have any other comment to add or to modify on this, the first algorithm, the cell estimation algorithm. Sorry. Next, please.
So sorry, Thomas, can I?
Yes. Okay. Of course. Yes. Go on.
So I know of multiple people who are implementing this at scale and trying it out using alternative 3.
Yeah.
So but this does not happen through for some reason I still don't quite understand. People are very, very shy and publishing results to the mailing list. But what I propose we do is Pascal, if you agree, we do a call for implementation, ready for implementation for this draft, and we ask people to
Feedback on that.
feedback on performance and implementability. This is exactly along the lines of what we discussed last time, Diego. So thank you for making
Yes.
these changes. I think now it's
Okay.
time to.
Yes, there was a, if we asked for that, it would be nice if we can get feedback on, there was a fourth way of doing things, which was to have a pool of shared slots. And because this really works rather well if you don't have many communication, many groups of cells, many bundles. If you over provision a large number of bundles, that's a large number of cells being wasted, mostly if things are stable. And the alternate model when you have a large number of bundles is to have a shared number of slots, which anybody who goes over his reservation can pick from. And from there, we can observe that this guy requires more slots, and then we can allocate them, right? But
Yeah.
kind of put in common this pool of cells that are used when you overuse your reservation. That's something we discussed long ago. I've not seen that idea progress very much. I'm not insisting that it's the right idea, but I just see that there are situations where what we have in R3 is really good. There are use cases, maybe if we have a number of peers where the shared pool of excess resource is actually a better idea. So I just want to make sure we have completely discussed this thing. So if we are looking at the alternates now, putting that one alternate 4 on the table as well could be a good idea.
Okay. Well, can you? I think we can go.
Idea, right?
Yeah, yes, we can go to the main list and discuss that, or I'll include it there. I think we can describe it just to compare with alternative 3, or if there's any implementation using alternative 4, maybe you can compare the performance on each of them, or maybe or just specify which will be the specific use case or if there's a general use case to suggest that we should use that 34 more than 3 or so on.
This is Xavi.
Yes.
Thomas, can you go 2 slides before? No, this one. Okay. No, that one. Yeah. So what Pascal's proposing, I think, would be good for SF1 or for SF2. But I don't think it's very simple to specify this, because if you have only one bundle, then you have shared cells that maybe you do not need. But if you have multiple, then you need to define when you start like merging cells and using them as being shared. So I don't know if this is very complicated or it's kind of complex for being the most basic scheduling function. And then from this slide, Diego said that you have over provision cells that are fixed in number, but I don't know if this is the best approach. It would be kind of a percentage of the cells that you allocate, because then the proportion of over provision should depend on the amount of cells you have and not have you a fixed number. So if you schedule only 1 and then you over provision like 2, you have too much, right? Compared to having a percentage. That's my feeling.
Let's continue on this on the mailing list. That's an interesting discussion, and that's kind of key to what we are doing here. So.
Oh,
Yeah.
you're back,
Yeah.
Diego.
Yes, just cut. Okay, don't worry. Okay, so we go to the next slide, please. So, okay, another item there. Originally we kept the difference, saying that we are talking about bandwidth, and we moved to cells, because originally we kept into account the individual packet delivery rate for each of the cells we are using. So, for example, a cell, the equivalence there shows that if a cell using 100% the packet delivery rate equals the same amount of traffic that a couple of cells using 50% packet delivery rate each of them. So we are just isolating both items. We don't map one to the other, and we just keep calculating the amount of the number of cells, and the packet delivery rate is taken into account by the cell relocation algorithm, which we are going to discuss later. Next, please. And talking about the sale allocation policy, we just went back because it was simpler, which was really stable and so on. Because we are using only the on-the-fly scheduling diagram, which worked very well for a time. And adding a new threshold was it's not working if we already have over-provisioning fixed on the other algorithm. So we are the only thing we are doing here is just changing the two arrows. Okay, just leaving on only one arrow on that side, and this keeps the original version of the cell allocation policy. This means that we are going to add cells whenever we go further than the number of scheduled cells, and we are going to eliminate the number of cells whenever we go below the SF0 threshold, less the number of scheduled cells. And in between, we are not going to do anything, and this stabilizes the behavior not to increase management traffic all the time. And this, of course, the threshold value is defined by the implementer. And next, please. So we are going to recover another phrase that we had on the original version, which just lost in the change, that the number of soft cells to be scheduled deleted for abandoned resizing is out of the scope. So the thing is, whenever we add or whenever we delete cells, the value of how many cells is dependent on the implementation. See, the question to the public or to the 6TISCH group will be if we can suggest a different value or a starting value here, okay, to work with, or just to leave it to implementers to do the job. So, next, please. So another item we are discussing a lot really was the timeout calculation. There's a really long discussion on all the basic sources of each of the elements we're calculating. But the point is the worst case timeout we can achieve is around 1 minute. So including all the timeouts which are coming from the MAC layer too. Okay, so since we are taking the worst case also on the MAC layer, this takes very long. And so the idea there is just to calculate only the timeout at the 6P level, okay, and then to leave the timeouts at the MAC level independent. That means that we could add a 6P acknowledge to override the MAC level timeouts. See, and that's what I proposed from Nicola, and we ask you if you agree on doing this. And this 6P acknowledge will propagate the MAC level acknowledge to the higher layer. So really, there's a long discussion on this. You can see it on the mailing list, but they have all the sources and all the reasoning behind this. Okay. The next, please. So, and just a little comment, okay, there's a condition on the 6P draft about this, okay, on section 411, it says that the scheduling function may define the timeout, and on section 5.2, they say the SF must define the timeout. So either 6P defines it or we define it, but somebody should define the timeout. So next, please.
Yeah, Diego, I'm posting
Yes.
an email to the mailing list to take this into account. Thank you for flagging this.
Okay. Okay, so about the 6 cell types on SF0. Since 6P now enables the use of shared transmission and receive cells on the scheduling functions, okay, the question is when to use each of them. From another recent discussion we had on the mailing list, the only type of cells we are reserving now is the dedicated transmission cells, and we don't have any information on any signaling telling us if we must define or must schedule shared cells or receive cells on the outgoing outgoing flows or outgoing traffic, in fact. Okay, so the thing is, which type of cells to schedule? We are just closing onto the transmission cells. Since we don't know if the incoming traffic is going to be going outside the same name to the same neighbor we are discussing with, and we don't know if the new cells are shared or not. Okay, we don't have information about that, so we cannot decide which type of cells to allocate there. In fact, we do not assume symmetric links. So whenever we schedule a transmission cell, we are not obliged to schedule a reception cell also. Next, please.
So Diego, just
Yes,
quickly,
yes.
this was
Okay.
something that was discussed very, very recently on the mailing list,
Yeah.
right? And I believe we decided to keep it just simple and have only transmit cells. Is correct?
Yeah.
Okay, so let's continue doing that then. Thank you.
So just to know how close we are with the compliance on the 6P requirements, we are missing only 2 items. In fact, the timeout, which is we have defined it, and really to discuss what really to specify there. If we add this 6P Act, which would simplify really a lot our task, and how to measure the packet delivery rate for the statistics. Okay, we are using the packet delivery rate to define the relocation algorithm, which is next. Next, please. Sorry, which is a couple of slides more. Okay. So talking about the performance evaluation, we have one one evaluation where we did quite maybe it was published this year, but was finished last year, in fact, in 2015, which used a different version of the estimation algorithm, but this one was specifically to test the allocation policy, in fact, which was the one which we're trying to analyze the best performance there. But we need further experimental evaluation, since with this was only tested with a simulator. So I asked for volunteers to help us on this issue. Okay, if you have any implementations where which you can share the results, I will be really grateful to include this on the draft, please. Next, please. So finally, SF0 about the relocation proposes that we are going to trigger a cell relocation whenever any cell achieves 20% less than the average PDR of the rest of the allocated cells, meaning that we are just measuring which is the link quality for every other link to the other neighbors, and if any cell drops below the 20%, okay, that will trigger a relocation and find another cell. There are 2 issues here. I just may mention one here, but one of them is just to add a relocation element there, the relocation command, instead of adding just to add a delete and an add command all together, so as to bring this as an atomic transaction, in fact, between the 2 nodes. And then we need also performance evaluation on this kind of proposal to see if this works, or we need to change this algorithm to a better one, or to another type of criteria to relocate the cells. We haven't tested it. Yes, this is just our proposal. So I think we are done. There was only. Yes, okay. So where there was just one more item, just as you mentioned, we had to comment here. Oh, I think we have commented yet. Okay, I don't know if I can remember. Okay, but I think that this is done. Okay. If you have any comments, I will be grateful to hear them.
So I think we discussed that we would comment on, what was it?
That's
I forget what it was.
That's the point. I just didn't take note of it. Okay.
Yeah, no, I forget. I forget.
Okay. Yeah.
Mhm.
Okay, that's the
And-
point of. Yeah, you have any comment? Yeah, tell me.
So, is there any? What do you ask from the group? I understand you want
Mhm.
feedback from implementations.
Yes.
That your main request?
Yes, in fact, feedback for implementation and comments on this server location algorithm, and specifically here, okay, because we haven't tested yet, and any other comment, of course, on the new versions of the alternative 3, in fact, which is the one which is most, as you mentioned before, okay, it is the most used.
But I think you'll only get these feedbacks from implementation. I mean, these are not theoretical questions, right? This,
No. Yeah.
You're asking for performance numbers, yeah.
Yeah.
Okay. So we'll do. Is that satisfactory to you if we do a formal request for implementation and feedback? Is that okay?
Yeah.
Is that
Yeah.
useful?
Yes, of course, yes.
Any more questions or remarks for this draft? See people saying no. Right, then we're right on time. We'll move on. Thank you so much,
Okay.
Diego,
Thank
for
you.
staying up. Now we enter into the second phase of this meeting about security. So we have to put it into context. We have 2 drafts that will be presented. There's been a lot of work on security, including in the security design team. And so we have 2 drafts, one that Marisha will present, one that Michael will present, and they address different levels of the security work. And I think, Michael, you have some slides that summarize it and put everything more into context. So let's start by the details, and we'll have Michael summarize that, if that's okay. Marisha, the floor is yours. Yeah, I have it here. Marisha. It's best if you just take it. Just take it in your hand. It's easy.
Please take it.
Yeah, good morning, everyone. My name is Malisha Vucinic, and together with co-authors Jonathan Simon and Professor Chris Pister, we published a draft that we call Minimal Security Framework for 6TISCH. And the draft is about the join process, namely how a new device termed the joining node can be admitted into the existing 6TISCH network. The entity that authenticates and authorizes the joining devices to the joining nodes to join is called joint coordinating entity, or JCE. And now, because joining node at the time of the join only has link local connectivity and does not have a global IPv6 address configured, it needs to communicate with JCE through a proxy that is termed Join Assistant, or JA, and that is a direct radio neighbor of joining node. Our draft makes the so-called one-touch assumption, which means that the joining node is pre-configured with a locally valid credential, and we assume either a pre-shared key, raw public key, or a certificate. And as the outcome of the join process, the joining node expects to be configured with a K2 from minimal and optionally a short 802.15.4 address. So just to give you an idea.
Sorry, Malisha, can you come back? So the last point, short 15.4 address, means that this replaces or does the same thing as the 15.4 association, right? This replaces the association. This is a secure association, and in the end, you get a short address.
Yes, the idea is the JC generates a short address for the joining node, and that it hands it out during the join process.
And so the JC, just to make it crystal clear, the JC is a central authority that makes sure that the short addresses are unique per node.
That's correct, yes.
Good.
And just to give you an idea of what constraints in terms of 6TISCH really mean, I did some initial emulations using OpenWSN of the join process, and the idea was to estimate how long the join process takes. And the assumption is that the border router is turned on last, and that the devices in the network are waiting for the network to be advertised. And the scenario was as follows: 30 nodes were in a single cell, fully meshed network, and there were 11 slots in a slot frame. And what you can see on the right is that the join process, in case the join protocol has only a single round trip, takes around 7.5 minutes. And in case there are 2 round trips between joining node and JCE, the join process takes around 10 minutes. Now, this is a pretty high duty cycle for joining. It's a 1 out of 11. In case a lower duty cycle is used, let's say 101, if we extrapolate with these results, this comes out to the join duration of 70 minutes in case of a single round trip, and 1.5 hours in case of 2 round trips. So we must be really careful how many exchanges we introduce in the join protocol, because taking these results into account.
One point, sorry,
Yes.
I keep asking you clarifying questions. So the 30 nodes fully meshed network are deployed, and then you switch on.
That's correct.
All right, so you have them all in a room, you switch on the gateway, and then you measure how long it takes basically for every node to send 1 or 2 packets up to a server in the cloud and back down.
Yeah, this result is for the last node. How long does it take until the last node to have joined?
Okay.
Subidas, a quick question. How many hops this network is?
It's a single hop.
And why this is taking 7 minutes?
Because for the whole ripple tree to form, due to all the collisions in the minimal slot and the retransmissions that take place due to the join protocol.
Okay. But do you have any data that which part taking what time? Like, that would be very useful.
I don't have, not exactly,
Okay.
but most of this time here, what you can see here with the single round trip is due to the formation of ripple, of the ripple tree. And then also it takes into account, obviously, the join protocol exchanges.
And JC is 1 hop away?
Yes, JC is 1 hop away. Yeah, that's correct.
So I think, just to put into context, this is not using the 6-hop protocol, right?
No, so this is pure minimal. I forgot to say this. So basically, this is pure minimal, a single slot, shared slot, and collisions take place in this slot.
Mhm.
And that's why it takes so long.
And
Worst case. It's the
worst
worst
case,
case.
But
right?
it's
And-
not the worst case. It's the case of join.
Mhm.
It's what we will have in join.
Yeah.
Yes, but this is what we have in join, right?
And 30 nodes come to the network 1 by 1, right? That's all. They are all on.
They're all started at the
same
same time. It's exactly the same time.
They all start at the same time, but they have a random delay of 1 minute, and the retransmission timeout of 1 minute. That is also used by.
So
SF.
is it fair to assume that this is because of the underlying physical layer limitation?
Yes, that's correct. Because of the physical layer, because of the MAC layer,
Mhm.
because of the schedule that we use for join.
Or schedule for that? Okay.
So I think the key takeaways are 2 points here. One is the 6-hop protocol is really important, because otherwise you're left with one cell only and everybody tries and use it, and there's a backoff mechanism. Backoff to resolve collisions, but of course backoff means you wait a little bit longer, and this increases the latency. So that's 1 point. 6-hop protocol is important. Second point is, if your join protocol requires 10 packets back and forth, there's just no bandwidth enough to deal with it. And so that's why we want a really, really lean, initial handshake.
Right. I think I heard also he was saying that scary, like it take like few hours. If
That's what we don't
worst
want.
case, right?
And that's what we, yeah.
Right.
yeah.
So that's pretty scary, right?
Mhm.
If it requires few hours to.
So that's the case if another slot frame length was used, because here what we used is only 11 slots in a slot frame. So this is a duty cycle of join 1 out of 11. If we use 1 out of 101, for example, then this goes to hours.
This is very useful, at least getting some real, into it. But
Mhm.
I think more data will be very useful.
Yep.
Yeah, and so this is just preliminary for now.
I think it also tells us about the prime we have with the shared slot, because the only way we get shared slot right now is the minimal. The SF only allocates point-to-point slots, and we don't negotiate shared slots. So for now, we don't have a way to increase number of shared slots. So that might become a prime as the number of devices grow, because we have to extend the slot frame, and there's still only one shared slot for all of them.
Peter van der Stok, an informative question. Do you randomize your access?
Yes,
Okay, what is the random
1
interval?
minute.
1 minute as well.
1 minute.
Okay, funny. Okay, check.
Yes.
So I think there's a, you know, there's a bunch of things we can do. I mean, there's the draft about sending RAs with IEs, which limits the number of packets, because now you have to imagine that in the shared slots, all the nodes are sending DIOs, they're all sending EBs, they're all sending RAs. So this is all, you know, traffic in that shared slot that causes congestion. So if we can group multiple of these packets together, then will certainly help. RA and IE being one example. So I mean, this doesn't scare me at all. This is what's expected. I just thank you for putting it up, just to give you an idea of like what we're dealing with here. That this is very low data rate. If you want to keep the power low, of course you trade off.
Yeah, Alexander, just a short question here. How long is the slot frame here that you're
It's 11 slots in a slot frame.
in time?
Oh, 10, you mean slot? 10 milliseconds.
Yeah, the time in 10 milliseconds. Okay,
Yeah.
because here in your graphic you have your results that are in terms of slots,
Number of slots,
and
yes.
then you have, yeah. So it would be also interesting.
100.
Well, I mean,
It's 100 slots per second.
okay, 100
Yeah.
slots per second. Yeah, because you were giving the, you know, it takes like
Yeah.
2 hours or
Yes.
something, and here have your graphics
Yes.
in slots. So I think it will be I mean, it's important, because if your slot frame is a different length, then the results could be shorter or longer.
Yes. So the default slot that we use is 10 milliseconds. Yeah.
But with this slot frame, you only have 10 slots to allocate to those devices through SF0. So it's not really realistic to have such a short slot frame. It's just to make the experiment faster, right?
Yes, that's correct. That's why I stressed, if we extrapolate these values, that we go 2 hours, basically. Yeah, so let me continue with our draft, basically, and taking these results into account, one of our goals was to minimize the number of exchanges, and we do this with a single round trip in case of pre-shared keys. Another important point to take into account is that the join protocol must have a very low footprint, which means that there shouldn't be any protocols that are used only for the join. Rather, we use the protocols that will be used during the lifetime of the node. And finally, we protect confidentiality and integrity during the join process of the join messages by using end-to-end ASCCM, that is an algorithm widely available in hardware. Okay, so I see there is no transparency. This is how the transaction diagram looks for our join protocol. Basically, the joining node sits and waits for the enhanced beacon in order to bootstrap layer 2. Once it receives the enhanced beacon, it synchronizes to the network and starts duty cycling. Then, in order to bootstrap layer 3, neighbor discovery exchanges take place, and up to this point, all of this is unprotected in terms of security.
Malisha?
Yes.
Just let me point out that this neighbor discovery exchange is just for the link local address. Right?
Yes. Yes.
We are not talking about any global address yet.
Yes. That's correct.
And with the RFC 6775 update, it really means only an exchange between the device and the 6LR. Because with 6LoP that would have meant going all the way to the 6LBR if you have a mesh. But now we are upgrading that at 6LO. So it's just a direct exchange with this node and the 6LR. In a mesh, it makes all the difference in the world. Okay.
The next step is the optional security handshake that takes place between joining node and JCE. The handshake is optional in case pre-shared keys are used, and it is mandatory in case of public keys. For the handshake, we use the ad hoc protocol that is essentially elliptic curve Diffie-Hellman embedded in co-op payload in order to pass over application level proxies. And finally, the two join messages are the join request and the join response that are protected using the key, the secret generated by the run of ad hoc, or in case the step was omitted, the PSK basically. The join response contains the K2 from minimal that is used in the network, and the short address, the short 15.4 address. We implemented the previous exchange using co-op, such that the joining node is a co-op client and JC is a co-op server. Join assistant plays the role of a co-op proxy and is made stateless by reading the application level information that the JN and JC exchange. The advantage of having JA application level proxy is that this is agnostic of the routing protocol and namely of the mode that the routing protocol is used in. Now, because our JA is an application level proxy, we were not able to use something like DTLS for protection of exchanges between JN and JC, and we used the new protocol from the core working group called OSCOAP that was recently adopted. And end-to-end encryption takes place between JN and JC end-to-end through JA. And it is important to stress that the actual traffic keys and nonces are derived from the PSK, and I have some details on this here. What you see here is how nonces are generated at the JN. And what you see here is basically the OSCOAP's derivation process, and what our draft does, it instantiates the process by setting the values on top. And basically, to get to the nonce, first the static IV is initialization vector is derived by passing through a HMAC-based key derivation function, PSK, sender identifier, label IV, algorithm identifier and key length, and most importantly, the context identifier that contains GN's unique identifier. And all of that is passed through a HKDF to get to the static IV, and the final nonce is obtained by XORing the static IV with monotonically increasing sequence number. This is at the JN side. At the JC side, it's very similar, except that the sender identifier field is different, and basically we just use value 00 and 01 for JN and JC respectively. 4 minutes. Yeah, okay.
What's the size of your sequence?
It is CBOR encoded, so
how many bytes?
Variable. It is variable, basically. It starts with 1 and then it increments.
Yes, but it's 1 octet, 2 octet? Is the long? What's the size of the number? How long does it take before it wraps?
So it's CBOR encoded. So basically, it encodes the length of the.
Yes, I'm asking just, do you specify the size of the sequence number?
No. It's this is in OSCOAP. This is OSCOAP's.
Maybe just to answer your question, in CBOR the numbers are encoded, so
but I'm not
from
saying,
1 to
I'm not
23
asking
it's
what
like
goes over
1
the wire.
byte, and then it's 2 bytes, then it's 4 bytes, then it can go to 64 bits of, I mean, in CBOR I think the maximum is like 64 bits or 128 bits.
But I'm not saying what goes over the wire. I'm just anxious of an implementation that would use 1 byte to store it, and after 256 iteration of this, you'll wrap the nonce, right? So I'm not talking about what goes on the wire. Just saying, do you have a recommendation for the implementation that is stored on a 4 bytes or something, so it's almost infinite in time?
And this increments every time a node joins, right?
For every join attempt.
For every join attempt.
Yes.
Right.
Yeah. So in theory, it's 1 join, but of course, if you reset the mode, it's always +1.
Yes, but what I saw in the emulations is that there were multiple join attempts because of the collisions.
Yes. So that's what I'm saying. We should recommend to store it on a large number, like 4 bytes.
Okay. Yes, so that was for the nonce, and the key traffic keys are derived in a similar way. It's pretty straightforward. I will jump to the example. So this is the example in case of pre-shared keys, and as you can see, it's quite simple and efficient. Basically, the JN constructs the co-op GET request and includes the proxy scheme option in order to designate JA as a proxy. It, as a URI host option, it includes the well-known host name 6TISCH.jc that JA resolves. And by doing this, JN never needs to learn JC's address during the duration of the join protocol. At the application layer, in terms of the context identifier, JN puts in the origin info object that contains its EUI64 unique identifier that is used at JC to look up the right security context to use. Once this request gets to JA consumes the proxy scheme option and forwards, just statelessly forwards the request to JC. JC looks up the right security context based on the EUI64, and if all the security checks pass on the OSCOP side, responds back with a join response that contains the key 2 and the short 15.4 short address, and this object is encrypted in the response so that eavesdropping is accounted for. That's pretty much it. Basically, the communication between JN and JA is link local. Between JA and JC is using global routes, global addresses, and existing routes. Yes, that would be all.
So, a couple of points. This means that JN goes through this before having even acquired any routing information, right? It just talks to the JA. It hasn't heard any DIOs or anything. It's not part yet of the routing structure because it cannot understand them because they're encrypted with a key it doesn't have.
Yes, that's correct.
Okay.
What is the size of these messages?
So here it is on the right.
In green.
In green, origin info encodes to 15 bytes, and the join response to 26 bytes in case of PSKs.
The document, can you go back one slide? I think it's right. So if I understand correctly, so both JN and JA needs to store this ID, this number permanently, because that's the only one that changes the key. So that needs to be, so the coordinator needs to store all of the nodes who have ever joined and their last number that they have seen from that.
Yes.
Actually, it's not enough to store the last number because they need to, might jump up forward, yeah. The recipient ID. And it's actually, yeah.
So no, for the role of JC, it's just 0, 1. Are you talking about the?
But then if you join again, then we get the same key, which is with the ASCCM is.
But the sequence number will increment, right?
Which sequence number? There is no sequence number there.
Here for the nonce, I mean.
Yeah, but this was the key generation.
Yes.
I assume
Yes.
this key is for sending for the encryption key
Yes.
for ASCCM,
Yes.
and it seems to be the same. If there's
Yes.
nothing there that's changing from.
Yes.
Okay, so are you saying the sender ID is always same, fixed? So this always generates the same key.
Yes.
Okay.
But there's a wait. I'm not understanding something. There is a nonce that's being changed at every time. Right?
Yes, that's correct.
And that nonce. So you're right. I think that the JC has to have a list.
The problem is that yes. So this ASN, we have an ASN that is also. I don't understand what the nonce here is actually, is because because it can't be the the 15.4 nonce, because that's generated in a completely different way.
Yeah.
So and I haven't seen anywhere used in this the nonce. If this would be using the nonce, then I think it would be a completely different thing. But I mean, the problem with the ASN and the 6TISCH nonce is that if you reset the whole network,
the
ASN can actually start from 0 again, and you can't use the same keys again at the next instance of the network. So you need to change the keys every time. So it has to have some kind of notion that the keys are going to be getting in differently.
So yes, I mean here the nonce will be different. So there won't be nonce reuse with the same key.
But which nonce we are talking about?
This nonce.
And
Because
where is that nonce used?
It is used for the CCM.
For which HCCM? The link level?
No, end to end.
End to end.
Yes.
Okay, so but okay, but is the key that you are generating, is it that going to be the K2 of the no, it's completely different key.
No, it's completely
okay, so
different.
You are not generating key at all.
K2 is generated by JC and is sent in the response.
Oh, okay.
And it's sent in the response of the join response. In the join response.
Okay, okay.
And this key is used to protect that message.
All right. Okay. Thank you.
So we're 5 minutes over time, so please.
Francesca Palombini, just to answer Pascal's question, in the mandatory to implement algorithm, I don't remember if this is the one that you used, the maximum sequence number is 7 bytes.
Yeah, no.
Stay there, please, Francesca. Something more for you.
Yes.
Actually, there was the core meeting yesterday, and since we highly depend on OS Co-op for this work, could you please give us a little status of what happened yesterday on core?
So I presented, so the draft, just for those who don't know, was adopted the last IETF meeting, and it was considered ready for implementation. So there was a call for implementations for SCOAP, and there will be interoperability test mid-January, hopefully. And so, yes, we are implementing this now.
I propose that if you have further questions, we go to the mailing list. We're a little bit over time. Thank you, Manisha, for presenting this. Michael? We're 5 minutes over time, sorry. Yeah, I'll try to go fast here. Hi, my name is Michael Richardson. Recap of the goal, is to bring as much of the commonality to a zero-touch thing between Anima, NetConf, and 6TISCH. So we are reusing as many pieces as we can without necessarily, as we discussed earlier, having billions of messages going back and forth. We had a bunch of discussion. We've had a lot of work in the design team. We concluded one of the things we realized was that we wanted to have a complete picture of all the messages. One of the things we realized is it would be really nice to eliminate some of the multicasts of the router advertisements since we're already sending beacons. So there's a document that the 6LO RA that I concocted, and there's going to be some changes to that. I don't have time to talk about that right. We're meeting Tuesdays. We're going to resume on the 29th if you want details of that. So the general process, and if you were in Anima yesterday, I explained some of the back and forths that we had in Anima as to inbound or outbound. But basically, we have a JCE, and it uses some kind of relay, and in this case, we go this way, and so malicious document goes the other direction, and we need to resolve what we're going to do that way. That's a very important thing. So this would be your typical Ripple network. This is the new node joining, and this traffic here is link local only. So this guy doesn't need an address to join, and he doesn't get an address until he has joined using the minimal process. Anima defines a massa and a manufacturer, and there's things called an ownership voucher that go through, and that's part of the part that we need to coordinate. Just so you see, this is what it looks like in Anima. The emphasis is the arrows are the other direction, and the technology is a bit different, but the contents are conceptually identical. Okay. Did I do that right? Oh, there we go. So manufacturer, the key thing is the manufacturer, zero-touch thing. Manufacturer has to install a certificate. In a one-touch thing, somebody locally has to install a PSK. The MASA is the manufacturer's delegated authority. That's an Anima term that basically provides a proof of ownership to the registrar that the device can validate. The JCE, as we call it, or the registrar as Anima calls it, makes the decision as to which pledges to enroll, and in particular, it decides on the order, and that's why we've made sure that we want to actually reach out and put all of the state machines and all of the ordering on the JCE. And the reason for this is because that way the JCE can actually realize that which devices it's going to enroll in which order and how much bandwidth it's going to do, because there's no point in spending 10 minutes
enrolling a device that keeps being unable to send packets in response. So the JCE basically can say, well, I only have bandwidth to enroll one device at a time, but I can do that in less than a minute. And so it's better to do one at a time and sequence it that way rather than having them all kind of stampede trying to join at the same time. So that's why the mechanism is controlled that way. That also removes the state machine from the end device as to, do I have a current certificate? What's going on? Are my keys stable and this kind of stuff? And do I need to wake up in the middle of my sleep cycle to renew my certificate? Well, the JCE would know that. So we've talked a lot about the joint assistant. The key thing is to keep the joint assistant as low impact code-wise and memory space as possible, using no state that the joint assistant wouldn't otherwise have as a regular node, and ideally as little extra code as possible. And so we have a number of different ways that we can essentially offload that state. Militia's protocol puts that extra state into the COAP, the ad hoc message, and that's potentially a very useful way. I was originally thinking IP-IP. We need to come to a resolution and figure that out. The new pledge is an IDEV ID. That's an 802.1AR concept, and the end result of the zero-touch join process is to wind up with an LDEV ID, which is a locally significant certificate. And once you've got one of those, well, then you can run the next protocol to get the actual key. We don't have time to talk about this slide with the difference between audit and ownership, and so we can come back to it or ask me in the list, but there's some distinctions between how the two different things work, and that's to support the variety of different ways that people will do things. The goal is, this is a heart sideways, so and the goal is to basically do this. So we have a zero-touch process, which is what I'm describing, and that's going to install a cert. We have a one-touch process that is out of scope. So I don't know, that means you boot it in a Faraday cage and do some magic. You push a button, you hook up a JTAG. I don't know. That's out of scope. We might need to describe some properties of this, but we aren't intending to describe it. They merge that together, and then you run 6TISCH manual. That's our goal with the process, is to integrate this. And I can't say that we're completely there yet. So issues. Right now, as specified during the joint process, we're using a GRASP request discovery and response between the joint assistant and the JCE. And that's a rudimentary admission control that basically says, is it even worth this pledge even trying to join this network? Because if the JCE just doesn't even know about that device, it's probably the wrong network. Probably, because it could be that the messages are forged and the the pledge is being lied to. So the pledge still needs to be suspicious, but at least this tells it, if you have other possibilities, you should go do them first and then come back and be suspicious. And maybe just no one's willing to have that light bulb join yet, because no one's actually received set up the right context yet, and it should just come back at us at a low rate. Right now, it uses TCP. Had a number of people say, "Oh, do I need a TCP stack in my join system?" I said, "Yeah, that's a good point. You don't want one of those." Okay, so we need to fix that. I don't know what the answer is going to be. It could be as simple as we define a COAP request response in COMI space or something. This request is not strictly necessary. It's an optimization to basically get rid of non-malicious nodes that are just lost or in the wrong network. We could do nothing. So ad hoc versus DTLS, we need to pick one. There's movement towards ad hoc. I'm very happy about that. I think we're making progress on that. Maybe there will be some pushback to the direction. I'd like to hear about that, but that's really kind of interesting. As I said before, we have to coordinate with 6TISCH minimal. In particular, do we want to make 6TISCH minimal go the other direction? That's a question. We could easily turn that around. I think we could do all the crypto the other direction, and that may work. But I don't know how to do that yet. How many documents? So there's a bunch of common write-up in 6TISCH minimal that perhaps we want to put in a common document and say that's there. So the crypto would be in one place, the process would be another place, the zero-touch certificate install would be in the third document. That's a decision there. RA and IE is a completely separate thing. It's an optimization. The decision, people said we don't want to build a general way of storing IPv6 packets in information elements, and we should just store router advertisement options, because that's really all that we're trying to get at for this. A new node coming along needs to hear a router advertisement to know essentially where its router is. And if we wait for a multicast or broadcast slot, that may be some time. So we have to wait for the beacon. There's no question about that. The beacon has, 20 or 30 extra bytes space in it that we could put something like this. Taro has pointed out that this is also useful for a node that has been sleeping for a long, long time, that needs to come up and is going to listen for the beacon, is going to have to pull the ASN one out to validate things, to know what's going on. And it would be good for it to know that that beacon actually is from the network that it's supposed to join. So it would be nice to have some identifier in that thing there that would help it. So that could be as simple as putting the DODAG ID in the beacon, so we can recognize this is actually the correct network that we should attempt to join again. So that document needs to be revised, assuming, pardon me?
I was just pointing that there was a work from DNA detecting network attachment.
Yes.
Which had a concept of link ID that we could have used here, but I like the root
DODAG ID.
better.
I think that's the right answer to do, because if you have in fact moved far enough that you're on a different LLN with a different DODAG ID, then you probably either need to start all over again, perhaps with your local ID doing minimal, or you should listen a little bit longer because maybe you haven't moved that far. You're just hearing two networks because a door opened or something. We need to figure out where to do the ownership voucher work. That is an open question between Anima, NetConf, and 6TISCH. I don't think we should do it in 6TISCH. You may scream and shout and say, yes, we should do it ourselves. I'm trying to get the various ADs involved to tell us what to do that way. It turns out there are 3 ADs, even though Anima and NetConf are both in ops because of the business. IESG members now don't always manage the working groups that are in their area. They have cross work. So we'd like to eventually get to a consensus call on the use of outgoing PCE to pledge method as opposed to incoming. One of the key things is that there are apparently some implementers that don't seem to trust that the JCE or the registrar will actually manage their certificate renewals properly, and would like to do that in the edge device instead of in the centrally, and others that want the exact opposite. And which way we go, determines where you put the state machine. So the advantage of doing the outgoing, I reach out to the device and I tell it, here's your new certificate. I know you had one. I know it wasn't going to expire for 2 weeks, but I'm giving it to you now because you're awake now or something. I know you're awake now. As opposed to the device wakes up and it's not 2 weeks later, but 3 weeks later, and its certificate's invalid and it didn't bother to do that. It didn't bother to renew in time running the state machine. So the point is, there is this, if you have an incoming process, then essentially the little device at the edge becomes responsible for its certificate lifetime. And if that's a piece of code you want to have in those small devices, well, it's not what I want to do. I think that's not valuable use of code space, but I'd like to have that conversation because I think it very much affects how we design the protocol. Is that fast enough? For 2 minutes left for questions?
Yes, perfect. We need those 2 minutes, but okay. Any question? But that would be like a 1 second question. You really a 1 second question.
Yes, very basic thing, Michael. I saw that the previous proposal says it provides the security, property, confidentiality, and integrity. Is this proposal provides additional features. Sorry, I just didn't read that anima. I just want to verify.
You're talking about this part of minimal?
No, yes. So this particular, yes, the design says that it only provides confidentiality and integrity. So that means my takeaway was that there was no authentication involved in that previous approach, right?
No, so the previous approach presumes that is simplest when there's a PSK between the two nodes.
Right.
So the PSK being private and confidential provides authentication. It's longer if it's raw public key or certificate. There's more exchanges in ad hoc.
Right. But
Okay.
in this proposal with anima, does it provide that if you use that, say, for example, you mentioned ad hoc, right? So just curious. That
Yeah, so it should provide everything. Yeah. I think the answer is yes, it does provide what you want if we're doing certificates. Okay. What it doesn't do, because we exchange the certificates at some point essentially in the clear or subject to man in the middle, it doesn't provide identity protection. Okay.
Okay, we have to close the list here. The meeting is ended. We'll be calling for adoption on those two documents.
Join us on the 29th.
Sorry?
Join us on the 29th for the call.
Oh, yes. I mean,
Yeah, that's probably
please,
the better
please
way.
announce it on the mail.
I'll do it today. Yeah.
Okay. So our idea is that really those two drafts are complementary, that the draft by Michael is the first stage which can get you to a state which is equivalent of having a PSK from which Manisha's work takes over. So what we want to do is call for adoption on those two documents in good faith that the authors and as a work group will help the authors make that a single streamlined process in two stages, with the first stage being optional. So I'd like to get a feel of the room of whether this is a good idea. So if you think it's a good idea to go for adoption on those two documents, please hum.
I would like to mention one thing, so with the second, that I think whatever group does, one security approach would be better, not two, one optional. And
So
it's not options, it's stages.
It's not two. It's one phase one and phase two of this of one solution.
Phase one being optional, right? If you have a PSK, you don't have to
We
go
don't have
through.
time, but
Okay.
it's one solution. Yeah.
It's two stages in one solution.
If it's not ready,
Right. So if people think it's a bad idea and we should hold it for a while till we've got the story straight, please hum. Okay, that's good. So we'll continue the work as a work group now. Those two documents will be called for adoption on the mailing list, and we'll call for like 2 weeks. We'll ask you to review them and then help us go turn that into the full story. And with this, any other business?
Okay, we hear nothing. Thank you very much.
Oh, please, if somebody did not sign the blue sheets, they are on the first table on the right here. So please come in and sign the blue sheets.